Okay, we'll go ahead and get started. We've got a lot to go through today. I've pretty much finished the project, the programming project or the lab, and I thought I'd show you guys my solution to start, and then we'll talk about stepper motors because like I said before we started recording, we can't spend forever on this. And the goal of the first lab is for you guys to learn Arduino coding, and I know some of you already know it to a large extent, but it's kind of trial by fire and learn as much as you can, and you'll get most of the credit if your game works, mostly. So don't worry too much about it. I will say I want this done by next week. So first class next week, I want it finished. And wherever you're at that point, we'll just call it done and move on. But I thought I'd show you the solution I came up with, and it might give you some ideas and maybe help you overcome some problems you may have still with your code. Anyway, in order to save space, not that it's really needed, but in order to save space, good, we can roll. What I did is I used a lot of defines. So you see here I'm including pitches.h, and I define a bunch of things. And all that does is the compiler, see the Arduino never sees this. What happens is the compiler says define means anywhere I see melody pin, I'm simply going to put the number 12 instead. Anywhere. That's all it does. Okay, and now there's more to it than that, but that's the way I'm using it. That's the way you can think of it right now. So all these different things, like why would I ever change LED 1 through 8? Well, I might want to change them to different pin numbers, but I'm not going to change those variables within the program. There's no need for them to be variables. So I just define them. Anyway, that's not very interesting. What you'll notice is I've defined several things. I've got trigger, coin switch, Mario theme, underworld, clear pattern, attract customer, random pattern, loose pattern, one pattern. These patterns down here, attract customer, all the 1 through 4, and well, even 0, those are numbers that I can set to request a certain LED pattern, because basically all of my light flashing on my LEDs is controlled by the interrupt service routine. And I'll show you that when we get there. Now, I needed another tune besides the two, the Mario theme and the underworld theme, and so I found a da 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 da. Now that's on tape forever. Horrible. You know what I'm talking about, when Mario dies. Oh. Right? I wanted that for the lose tone. And so I found some code that did it, but they did it differently. So I just basically copied what they had rather than using pitches.h and rewriting their melodies in this form. Why bother? I don't want to waste the time. I just want to get it done. So anyway, so here's the Mario melody, the tempo, both in arrays for the Mario melody, then the underworld melody, and the underworld tempo. And you guys have seen that before because of the link. I just copied it from the link that I showed you guys. And the link's on Blackboard. Now, one level melody, I don't know why. I know why. I was trying to do it. I was trying to do the conversion. I finally said, forget it. I'm not going to mess with it. So this part I should just take out. You see it's commented. It's not doing anything. Okay, storage variables. A lot of the variables I deal with have to be addressed, read or written, by both the main code and the interrupt service routine. So I had to make them volatile. So I've got several. I've got a counter, essentially I, which you've seen before. That's in my interrupt service routine for lights. I've got a definition of what is the current LED. So what LED is on right now so that my code can know. And I didn't really have to set it, but I went ahead and set it to LED 1 just to start. And that was more for testing. I could leave it undefined. I could just put the semicolon immediately after that. I've got a couple variables, time count, game credit. Game credit is just if you press the button more than once, I wanted it set up so the user could insert several coins. That way we get to make more money off this game, okay? That was my idea. LED pattern, that's where I set the first LED pattern, which is just clear. I'll set it to 0. And then when LED equals LED 1, again, I don't have to set that, but I did. And then life count is another variable that I've got to 0. Life count and game credit are two different things. So you get 3 lives for 1 credit. So I want to keep track of how many coins the person had put in and how many lives they have. All right, the setup, this is just defining the pin modes. There's my buzzer, there are the LEDs. And of course it's super simple now. If I ever need to change different output, I can do it in the defines. I don't have to do it here. And there's still LED 1 through 8. I had the trigger, that's the game button, and then a coin switch for detecting the coin input. And you'll notice here I've removed the pull-up resistors from my circuit, I'll show you that in a moment, and used input underscore pull-up instead, because there are actually pull-up resistors built in, and you can use them. Just you don't want to use an external pull-up or pull-down if you've got an internal pull-up on. All right, so then here's where the magic begins. I attach interrupt to coin switch, and I'm sensing the rising edge, okay? Now serial begin, that was just for troubleshooting. I could actually eliminate that now. I don't need it anymore. I didn't actually write anything to the terminal when the program is running. You guys have seen this before. This is where you're clearing interrupts, setting the interrupts back on, and setting a timer. I'm only using timer 1. And basically I just set it to run at 10 hertz. So in other words, the timer is done every, tenth of a second. So there are 10 interrupts per second based on time. And hopefully you guys have seen this, and I showed you how I did that last time. Now, you haven't seen this. This is my new and improved interrupt service routine. You recognize part of it. Every time I come into the service routine, I need to remember that another interrupt has been triggered, because that's how I'm keeping time in all this code. Okay, that's really the kind of the heartbeat, and I need to know where I'm at. So I just add 1 to I. That's what I++ means. Take I, add 1 to it, and put it back. Okay. Now, I improve the interrupt service routine by adding a switch case statement. So the switch case statement, if you're not familiar with it, it's kind of like an if-then, but with multiple thens. If it's this, then do this. If it's this, do this. If it's this, do this. And you have multiple different cases you can accommodate. So I'm switching based on the variable LED pattern. So whichever LED pattern has been requested, whichever one is set to on, that's the pattern I want to display. And I've got several different ones. You'll see them when it runs. All right, if I is 3, now remember I is the count. If we've come into this routine 3 times and the LED pattern is set to attract customer, then we're trying to attract the customer. And what I did is I wrote a program, or wrote a routine, that would simply start at the 2 center LEDs and work its way out and then back in. So it's just going back and forth. So it's just motion to try and attract the user's eye. So I couldn't think of a more clever way to do it. So I just said, if we come into it 3 times, then turn on the LEDs just outside of the center of the pattern. And it could be that we're doing this over and over again, so we might need to turn off the LEDs in the center, because remember, it's going to move back and forth. Now, each time I come into the interrupt service routine, depending on how far along we are in time, at 3, 5, 7, 9, and so on, that'll determine exactly which lights are on and which ones have been turned off in the previous step. Does that make sense? Kind of? So that's all I'm doing here, and I'll demonstrate that for you in just a moment. So the key to understanding the interrupt service routine is I know I'm going to come back into this routine over and over and over again. I don't have to sit in this routine and make the lights go back and forth while I'm in the routine. I can just go into the routine, turn on the next set of lights if it's time, and then leave the routine. And I know eventually I'll come back in here, eventually more time will be accumulated, and I can turn on the next set of LEDs, turn off the ones I turned on before. So you'll notice at this time step, I'm turning on LED 3 and 6 and turning off the 2 center LEDs. Well then, next time step, when we come into the interrupt subroutine 2 more times, then I turn off the ones I turned on before and turn on the next ones out, and so on. And you'll notice this pattern continues until finally the first few were moving out, and then these were moving back in. Now this is kind of a trick here. I say else if I mod 2. What the heck is that? Well, when you take a variable and divide it by another number, it's possible to have a remainder. If what you care about is the remainder itself, then you can actually get that remainder, use the mod command, and that's what this percent does. So let's take it for instance. Let's say I is 10. What's 10 divided by 2? 5. Okay. What's the remainder? 0, right? So this instruction, if I were 10, would return 0, which is a false, right? So else if false, well, it's not true, so it goes on. Now let's take another instance. You see the largest number here is 11, right? So when we come into this routine and I is equal to 12, 12 divided by 2 is going to be 6, no remainder, 0, so we won't do this. We'll come into the routine again. And now I will go to 13, because remember I++ at the very beginning, we add 1 to it. I is 13. What's 13 divided by 2? 6. What's the remainder? 1. So now I've got a 1 in here. So it's triggering on odd numbers. If one of these routines have not picked up the odd number, by the time we get to 13, this one will. Okay. Now I use this mod command to show it to you. I could have simply said if I is 13. right? That would have been fine. But I wanted to show you this trick because it's a really neat trick for detecting, well, this is simply a trick for detecting even versus odd. That's all it really is, okay? So, and plus I wasn't sure how many of these I wanted, and I knew I wanted to trigger on the last odd number that wasn't already detected here and dealt with. Okay, so else if I mod 2, in other words, if I is an odd number, then let's start the light pattern in the center. And the reason for this is so that I can begin the light pattern. You got to start somewhere, and that's what this is for. Now what it does is then it digital writes the center LEDs on, and in case the other LEDs were already on, turns them off, and then sets I back to 1. Okay. I could have set I to 0. It doesn't matter really. So the idea here is let's move back to the beginning pattern. Okay? And then there's a break, because remember, this if then else structure is inside of one case. This is just one case. There are 4 other cases. There's the random pattern, and I showed you the random pattern before. The random pattern, okay, yeah, we're fine. The random pattern, if I is greater than or equal to time count, set I to 0. Okay, so this is a different case because this is when we want a random pattern displayed on the LEDs. Okay, digital write the current LED low, get a new current LED, and then figure out how long that current LED should be on. Again, this is a random amount of time, and then digital write that LED high. So this current LED is different than this current LED because we've changed it in between. Okay, so we're just getting a new LED and turning it on. And so what happens is, then we come back into the interrupt service routine. I is incremented. If I goes greater than time count, we go into this, and time count was defined here. But most of the time, that's not going to happen. Most of the time, this is going to be a decent number, say 5. So we got to come into the routine 5 times before, okay, I is greater than or equal to time count. So now we get a new LED. You know, choose one at random and choose at random how long it'll be on. So the key to understanding my interrupt service routine is that I'm not really spending a lot of time in the interrupt service routine, even though it's very long. It's more of a, okay, which pattern are we in? Once we've decided which pattern we're in, do one thing to that pattern, then get out of the subroutine. That's what it does. So it looks long, but it's not like the code goes through all of this, okay? So even this code goes through pretty quickly. All right, what about a lose pattern? You haven't seen this yet. The lose pattern I decided on was sort of redundant because I needed a routine to flash the chosen LED, the target LED. And so I decided that the lose pattern would also be flashing the target LED. Does that make sense? So you remind the user, no, you pressed the button on the wrong one. This is the one you should be hitting. So this one's pretty simple. Remember, I is keeping track of how many times I go into this routine. It's incremented automatically every time I go into the routine. So if we need a lose pattern, if lose pattern is set, if that's the value of LED pattern, then as long as the count of times we come into the routine is fairly low, we digital write the win LED high. Now I could have done it better because I really don't have to write it every time we go into the routine, but I was lazy and I left it that way. Now, if I goes above 10 and is still less than 20, then we turn the LED off. Else, in other words, if I goes beyond 20, then we set I back to 0. Now, if you think about it, as long as lose pattern is set, this LED is just going to keep flashing over and over because we're going to keep going into this routine. I will continue to increment and be reset, and it'll simply keep flashing. So my main code has to change the LED pattern from lose pattern to something else when it's ready to continue the game. But this interrupt service routine is just like a servant. It just goes and does whatever it's told to do. Okay? And right now it's being told display the lose pattern. Win pattern. I decided on something simple for the win pattern. I decided I wanted a quicker flash, and so for I less than 2, I actually digital write all of the LEDs high. If I is less than 4, in other words, as time moves on, we've gotten past 2 times into the routine. As long as it's less than 4 times, we turn them all off. So this way, all the LEDs will come on and go off together. And I'm using essentially what's known as a for next loop, although you don't use the next terminology in Arduino syntax as far as I know. And all I'm doing here, I tried to throw in a lot of variety so you guys could see different ways of doing things. I define a variable in the context of the for loop that's an unsigned integer, and I set it equal to LED1. And then as long as N is less than or equal to LED 8, do this, and when you go into it, add 1 to N. So this is cycling through N. It's taking N and increasing the count of N over and over. Now this is going to happen inside of the interrupt service routine, but it's going to go very quickly. If I was having trouble with this part of the code, this is probably the slowest part of my interrupt. If I was having trouble with it, what I would do, the digital write actually takes a decent amount of time. I don't remember how much time, and there's ways of hitting the registers directly where you can make outputs go high or low without using the digital write. Okay? So all I'm doing here is cycling through turn LED 1 on, turn LED 2 on, LED 3 all the way to LED 8. That's what this does. Now, as we come back into the interrupt service routine and time continues to go forward, then when we're past two instances of the interrupt and we're less than 4, then I just recursively turn all of them off. And you'll see the effect of that in just a minute. Yes?
Can you explain the unsigned and how it...
Unsigned, yes. Okay. When you have an integer, I don't remember what size it is. Do you guys remember right off what Arduino defines an integer? I think that it's 256, but I'm not sure. Let's find out. The variable type is an int. Integer is primary, yeah, 16 bits, so 2 bytes. So if you just declare a variable to be an integer, that integer can take on a value from negative 32,768 up to 32,767. Now if you think about it, a 16-bit byte, or a 16-bit word really, can go from 0 to 65535. That's the same difference as this is. Well, when you say unsigned, you're saying it's going to take on values from 0 to 65535. When you don't declare unsigned, then that variable can take on this range of values. It's still the same number of numbers, it's just a different range, it's just shifted. Okay, so what I'm saying is I don't need any negative numbers in this variable. Good question. Anything else? I know we're moving pretty fast. Mr. Smith, welcome. I hope you're feeling well. I know you may be a little under the weather. We're just going through the code that I wrote for the project solution. And I will warn you guys, my code is not perfect. I still have some bugs that I haven't figured out yet. But I'll show those to you as well. I'm sure it'll fail for you. Okay, so then the default case, because remember, this is still a switch case statement. The default case is to simply turn off all the LEDs, and that's what I called clear. So if I set clear pattern, which is 0, or anything else, anything other than 1 through 4, it'll simply turn off all the LEDs. So that's how my interrupt service routine deals with the lights. It's basically a little minion I have on my side that I say, hey, I want this LED pattern, it goes and does it for me. And I have to tell it when I'm done with that pattern, I have to set a different pattern so that it will stop flashing random LEDs or whatever. Okay, the loop, here's the main portion of the code as far as we're concerned, the Arduino is in all of the time. And there's a little bit to this because I'm dealing with the structure of the game itself. So while game credit equals 0, as long as a coin has not been inserted, okay, then LED pattern equals clear. Now, you might say, well, how does game credit get set? Well, I've got another interrupt that sets the game credit. I've got another interrupt that detects when a coin is inserted, in other words, when a switch is pressed on that particular input. And I'll show you that in just a minute. But just trust me, that's another little minion I've set up to automatically detect coin presses and change the value of game credit for me so that I'll know, hey, it's time to play the game. The user has bought a game. Okay. So as long as the user has not bought a game, then let's set a clear pattern. Okay, that's the first thing I did. Delay for just a very short time. And the reason I have to set a clear pattern is who knows what we did before I came into here. There could be an LED on somewhere. I just want to turn it off. This is not very long. The reason I set the delay for 120 milliseconds is because remember that interrupt service routine is only triggered one time every 1/10 of a second. So theoretically, I could have waited for only 100 milliseconds or 0.1 seconds and it would have been called, but I wanted to make sure. So I waited for 120 milliseconds to make sure that the interrupt service routine is called and the lights are all turned off. Okay, so LED pattern equals attract customer. Okay, so what I did there is I just told the minion which pattern I need. Remember, that's the movement back and forth. And now let's go and sing Mario thing. So it's singing da 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 da. And since I set LED pattern to attract customer, then the LED controller, basically that interrupt service routine, will be moving lights back and forth. Now we've seen a lot of code. Why don't I demonstrate this for you? And I'll try to hold it up for the camera, especially for those who are in Anderson, but in case you guys go back and watch this. You'll notice on my board I no longer have the two pull-down resistors. I've replaced those with the internal pull-ups. Well, I don't remember how them as pull-up or pull-down. It doesn't matter really. But I've got a switch here, and this switch is for inserting a coin, I think. Yeah, and this switch is for playing the game, okay? So I'd really like to replace this one with a photo switch, like you did, Mr. Pleiss, so that I could actually roll a coin through it and it would detect the coin. As usual, I've got my 8 LED outputs here, and then here's the Arduino. So if we hook it up, let's see, it should, I've already got the program downloaded, so we'll just, see the light pattern? That's to attract the customer. Remember I was talking about the lights moving out and in. Okay, so that's the attract customer pattern. So we're trying to get a customer to insert a coin. So here comes a customer along, they insert a coin. Now this button is served by an interrupt service routine I've not shown you yet. But when I press it, it'll change game credit and increment it. Okay? So it immediately stops. And it's flashing a light. It flashed this light up here. You might not have gotten to see it. But it flashed it 3 times to let me know that's the target LED. Now there's no sound during playing. We could make some sound during playing, but I don't have it. Where are we in the code? Right now, we are in this next section because look, after singing the Mario theme and the user has inserted a game credit, which is what I did. I inserted a quarter by pressing that button. Then I waited for a second. Set life count to 3, so give the user 3 lives, and then subtract, wait a second.
And subtract 1 from
Yeah, subtract wrong from game count. For some reason, I keep getting confused between life count and game credit. Even when I was coding it, it took me a minute to realize those are 2 different things. So the user has 3 lives. Now, that's why I added this comment, but I didn't read it. Charge user 1 credit. Okay, so we're charging 1 quarter for this game they're about to play. So this is the game itself. So right now, we're in this loop. While life count is not equal to 0, okay, which we have plenty of lives, we've not lost one yet. When LED equals random, so select a random LED for winning. LED pattern equals clear, that's already happened, we cleared it, right? Delayed just the 120 milliseconds to make sure that all the lights were turned off. And then set LED pattern to lose pattern. Now the user has not lost yet, right? Remember, it flashed this first LED 3 times for me so that I would know what the target LED was. So it's kind of a misnomer. Really, I'm just telling the user, here's your target. And then I waited for 3 seconds. So now waiting that 3 seconds, remember the minion is off, the interrupt service routine is off, flashing the light for me at the frequency of once per second. Okay? So I know I have to delay here and wait while the interrupt service routine flashes that light. I don't want to jump into the game because the light's not been flashed for the user to know which one to play. So anyway, then finally LED pattern equals random pattern. So now that's what's going on here, right? We've got a random pattern moving around. And then I said, while digital read trigger is 0. Now, this is exactly where we are right at this instant in time, because what I'm doing is I'm reading the trigger, which is right here. Okay? I'm reading the trigger over and over, just waiting for the trigger to go high. Right now it's low. I have not pressed it, right? So I'm just waiting for it to turn off. And remember, now if I'm here and there's nothing going on, how are the lights moving around?
The interrupt action.
Exactly, the minion, right? Remember the minion that's controlling lights for me? That interrupt service routine is continuing to move the lights around at random for me, and all this code is doing is just sitting there waiting for me to press the button. I was thinking of using an interrupt service routine for the trigger button as well, then realized it was unnecessary, because there's nothing else literally for the code to do while it's waiting for me to press the button. Now I could, if I had put a song in here for there to be music during the game, okay, then I would need to use an interrupt service routine to service this button. And the reason for that is while the game is playing, the song would be taking up all the processor time. Okay, well, not all of it, but all but what the interrupt service routine is doing, flashing the lights. And I would need to interrupt this code somehow in order to determine whether or not the user's pressed the button on the right light. So let's play the game, and I'll hold it up where the camera can see it. Now I'm going to choose the wrong LED on purpose. Okay, so that's not the LED we want. Come on. It should be giving me a... Is this hooked in okay? I think that my wire, yeah, my wire came out. All right, let's try again. No? There we go. So I missed the target LED. Okay, so now it goes back into play in the game and letting me try to hit the light. I don't know why that light's on. That's a new bug I've not seen before. Don't know how that happened. Let's see if we hit the light, what happens. Actually, let's try losing another life. You ready? The target is moving around. I don't know why. I've got to figure out what I've done wrong there. Let me try hitting the right one. I think it's just flashing the wrong LED, but it wasn't doing that the other day. I'll figure it out. It's generating a new random LED each time that I lose a life. There we go. That was the last one I selected. So there's my wind pattern, just flash all on and off. Okay? All right, so let's see the rest of this code quickly and see how it works. Let's turn off the speaker because that's going to get annoying. There we go. All right, so this is where we were when we were playing the game. And then when the trigger is pressed, then we go out of it and check if current LED, whichever LED it is on, is not the win LED, then subtract a life. Clear the LED pattern, make sure we got enough time for the LED pattern to actually be cleared by the Nrab service routine, and then set it to the lose pattern and sing the lose pattern song. Okay? That's weird. Why do I have it singing? I don't remember.
You call it Underworld, but apparently it's singing the death song.
No, that's not right. The death song is a separate function. The death song is this one. Level clears, that's right. That's right. I used Underworld as the death song. This one is level clear. That's right. You remember at the end when you would jump on the flag with Mario and da 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 da. That's the one you just heard. So that's, I'm sorry, I did this a couple days ago over the weekend. I've kind of forgotten it. All right, so sing Underworld, that's losing when we lose lives. On the other hand, if current LED is equal to win LED, if it is 1, then clear the pattern, wait for the pattern to be cleared, set the win pattern so that all the lights are flashing, and play level clear, which is this. Now what's interesting about that is that we actually are done with the game at that point. It really doesn't matter how many lives the user has. They've won and that's it, the game's over. Okay, now I had to break twice because I was having trouble getting it to break out of the entire while loop and go back to here. So that was one of the bugs I had, and I still. Did you figure it out?
I figured that out.
Okay, how did you do it?
So basically, the Arduino's response time is fast enough that by the time that else finishes,
Yes.
it hasn't gotten around to reset to changing everything properly, so it starts the loop again.
Well, I want it to start back here. That's what I want it to do.
Right, I'm saying, so in the while life count loop, okay, if you win or lose, either one,
Right here?
okay, when you go into the else statements,
Right.
the time, there's not enough time between when the else stop statement or the if statement finishes
Mm-hmm.
and when it gets back to the top of the while.
So what do I have to do, put a
life count.
delay in before the break? Ah, okay. I'll try that, thank you. Yeah, I tried 2 breaks, and it seemed to help, but it still wasn't good enough.
Yep.
Yeah. Okay, I'll try that, thank you. All right, let's see. This is old code I didn't use. There's like I said, I was lazy. I didn't feel like converting the song over to the other format, so I just used the function I found to play that last song.
You should have just asked me, I had it done already.
Oh, did you? I
Yeah.
could have copied it from you.
I have
Fellas,
the win and the loop. I have the win and the loop. That's
I thought over the weekend, I thought, you know what, I'm just gonna get this thing done. So I'd been working on it a little bit at a time, like adding a new LED pattern to the interrupt service routine. And finally I thought, you know what, I'm close, I'm just gonna figure out. And the last bit I had was this game code up here, so I did that. And I needed another melody, so I just copied it and was done. All right, so here's the same function. You guys have seen that, there's no point in going through that. The one thing I will note is that if one of the questions I think you guys were struggling with was how do you interrupt a song? When a song's playing, how do you get that song to stop playing? Well, you have to modify the function that's playing the song, right? You got to get it to stop somehow. Here's how I did it. I did it two places. First of all, sing basically chooses the note and how long the note needs to be played, and then calls another function called buzz to actually play the note. Okay, that's how it works. So what I did is I decided, you know, if we're done playing a note and game credit is more than one, more than or equal to one, right? Or more than zero, same thing. Then break out of this function, break out of this if, and it'll go back, or actually break out of the for loop, and that would end it. That would end the function, and then we go back. But I didn't even want to wait. If there's a note playing, I did not want to wait for that note to finish playing. Okay? Now you'll notice I've done the same thing here, and the else, the if else, let's see, why is there an if else? If song is underworld, because there's two songs. So I needed to break out of both songs. And so I did the same thing there after the buzz command to break it. So it didn't matter which, whether I was in the first case or the first song or the second song, it would break out. But also in buzz, I didn't want to wait for the tone to end. And here's where the tone is actually being played. And the way it works is the output is turned on and off at a high enough frequency to make a particular pitch. The faster it's turned on and off, the higher the pitch, the lower the pitch. So delay value just gives you a pause between when the speaker's turned on and off that makes the tone the correct pitch. So I decided it's not going to take very long between turning on and off that speaker. And I don't mean turning off the tone, I mean literally pushing the speaker back and forth. That's not going to take very long because you're talking frequencies of, you know, probably at least 200, 300 hertz. Now higher pitches are going to be around, 3,000.
I would say most of the game takes around the 400-ish hertz range.
Right. So A440 is what, A in the,
A in the
is that
staff.
the third register? I can't remember what register it's in. But anyway, the point is this doesn't take very long. So I could just wait till it was done and say, okay, if we now have game credit, then break out of this. We don't need to continue buzzing the speaker. I didn't want to wait for the tone itself to end. You could get away without this, and all that would happen is the tone would finish playing for whatever duration is required, and then it would break out. But I wanted it to be a little more responsive than that. All right, so then,
No.
here we go. Here's the last one you've not seen. This is another interrupt service routine. Now, the first interrupt service routine I wrote is triggered based on time. Okay? So this one is not. This one is triggered based on a coin being inserted. Okay? So what I've done, where I attached interrupts, let me find that quickly. It's far away. I probably should have put it next to that one so it makes more sense. But somewhere I said, oh, you have to put it in setup. That's right. Never mind. Okay, so attach interrupt. When there's one particular input that is the coin switch, right? I'm going to have a photo eye connected to that so that when a coin is inserted, it's detected. That's what this is doing. It's saying anytime this particular input is rising, call the program or call the function coin inserted. That's what that attach interrupt does. It connects the switch to calling the function. So whenever that switch is pressed, the function is called. Now that function at the very end, right here, so as soon as you insert a coin, what's going to happen is that will automatically trigger this to be called. Now this is kind of interesting. For those of you that are struggling with debouncing, I actually debounced in here. And so you may be interested in this. So I declared a static unsigned long. What the heck? Well, unsigned means we're not going to have any negative numbers. Long means that this can take more numbers. It didn't really have to be long, but I made it long. Well, no, it does have to be long because I'm counting a lot of things here. Anyway, so this is a fairly big variable. Now static, what does that mean? Well, that means we're going to declare it once. and it's gonna stay in memory. I don't want you to destroy it after I've declared it, and I don't want you to re-declare it later. So this, what'll happen is, when it gets to this point, that variable will be set up in memory and it'll stay there for the rest of the time the program is running, until the Arduino is reset. Okay? So I'll explain what this is for. Let's think about debouncing for just a minute. What did I say would call this function? Do you remember? Coin inserted. But what feature? Was it being high? What
It was rising.
It was rising, right? So if you think about a mechanical switch being pressed, what happens? Well, it rises and then it bounces and falls, right? So there could potentially be multiple rising edges detected where this thing's just getting called over and over again, right? And that would mean that the user is inserting a bunch of quarters. Wouldn't that be nice in video games, right? You insert one and it counts it as 100 because the mechanical switch bounced. Okay, I don't want that. I want the first rising edge to be counted, but I want the remaining rising edges to not be counted. Okay, so how will I do that? Well, what I did next is I made a variable called now time. It's also long and not negative, but it's not static. Okay, and I set it equal to millis. Now, millis is just the free running clock inside of the, well, it references the free running clock in the Arduino. As soon as you turn the Arduino on, there's a timer that's just counting up time, running very fast, okay? So I just went and grabbed, it's kind of like looking at the clock, okay, when you're timing something in the mic or in the oven, right? I looked at the clock and remembered what time it was right now. There's got to be a Spaceballs joke in there. You guys remember that scene? Maybe not. If you've not seen Spaceballs, don't watch it with a kid, but I like it. It's hilarious.
I watched it as a kid.
I did too. But, you know, I don't know what your standards are for your kids.
Now.
Exactly. So anyway, so this is just recording what time it is when we get into this routine. Now, if now time, not right now, minus last trigger time is greater than 100, what is this doing? Well, it's actually calculating how long it's been since this function was last called. Does that make sense? If it's more than 100 milliseconds, okay, well, then this must be a new button press, right? Because what I'm assuming here is that when the button is pressed and it's bouncing, that it'll settle out within 100, is that 100 milliseconds? That may be 100 microseconds, I don't remember. Because millis is in microseconds. Yeah, so I assume that 100 microseconds is how much time it would take for the switch to settle down. So remember, this is going to be, this routine will actually be called every single time that the button bounces. Right? So in a way, it's wasting time. Maybe if I had done this in hardware instead with a capacitor or something, then this function wouldn't have to be called. I wouldn't be wasting processor time. But it's not a very long function. So I just let this function be called over and over. But the only time I increment gain credit, in other words, say a new coin has been inserted, is when it's been enough time since the last trigger. Does that make sense? So that way I come into it and look at it, but I neglect all of the spurious transitions. And anyway, so once this is true, once it has been long enough, well then I have to set last trigger time to now time. Because I want to remember for the next time that I'm triggered, whether or not enough time has elapsed to indicate that this is a new coin. Okay. By the way, I found that. I didn't figure this out. I found it and then modified it. I did a quick search online.
Is that the one I found?
Showed it to you. Yeah, you may have found it as well. I don't remember.
It looks like the one I found.
What did I search
Debounce.
for? Yeah, I searched for Nrab debounce. Yeah, there it is. Is this the one you saw also?
Maybe. Hold on, where's the code?
Okay, so here's what the person recommended. It took me a while to wrap my head around it to figure out what was going on and was it really the way I wanted it to work. There was actually a suggestion in a comment below that was correct. Do your thing in my case is adding 1 to the game credit. But I agree with the poster at the end that says this needs to be inside the if. And if you think through it, you can understand why. But anyway, that was down here. But you had to read through this to understand what they were recommending. But whenever I'm coding, what I do is I try to run the code in my head, if that makes sense. I try to step through it and say, okay, if I'm the Arduino, what do I do in this step? What does this mean? Static, unsigned, long, last interrupt. Well, I go look up what static means because I'd forgotten. And they say, oh, it's only declared once. And so we'll always have this last interrupt time variable sitting there that we can look at. And then I just considered how, it's kind of like I developed the algorithm in my head. You know, if I don't have this code, what do I do? Well, I think about what's going on. Well, the switch is going high, going low, going high, going low. What would I want to do? Well, it's kind of convenient that I'm detecting the rising edge. That's good. But what I want to do is just ignore any rising edges that occur in a short period of time. Okay? So then you can figure out the algorithm
Do
and
you
write
have
it.
D-mounts for your button press on the
I
other
do
one?
not, and that's probably why I'm having a little bit of trouble with it. I don't have to bounce on, well, no, wait a second. In a way, it would be to bounce, because look, in my code,
Because you have the pull-up?
no, because it's a while.
Oh,
The pull-up doesn't change the time. But it's because I'm in a while loop doing nothing. Where is that? Same tune as void loop.
I see it, yeah.
Yeah, see, so I'm in here. As soon as the first trigger happens, I don't care if a bunch of spurious things happen because I'm always going to delay at least 120 milliseconds. So the bouncing's well done by the time we're through here. So I didn't need to bother debouncing that switch. So I still have other bugs, and I'm not sure where they are, but I'll figure them out and share them with you guys eventually. So my goal is that you stick a fork in it and call it done by Tuesday. Okay? So 1 week from today. Anderson students, I'll give you a little bit more time because of the way that the course has a little bit of a delay. But like I said, the goal of this first lab is really, well, not first, second lab. The goal of it is just so that you get your feet wet in Arduino programming. Okay. Any questions or comments? Well, I know you guys are tired and bored with this, and I don't blame you. It's very difficult to wade through someone else's code and actually understand what's going on. So you're welcome to come up and look at my code if you want. I don't intend to post it. I might post it if you really, really want me to. But I don't know how. Actually, you know what the goal of this is learning? I think I will post it for you guys. So you can look through it. But don't just copy what I've done. Try to think through it, okay? And as I said before, I'm probably going to give you guys most of the credit anyway for the labs, even if you don't succeed 100%. But I need you to learn how to code the Arduino so that we can do more. Why don't we take, I'll wait until the hour rolls around and I'll start talking again about stepper motors. You might want to get a Mountain Dew or whatever it takes to stay awake because this is going to be boring. I apologize for that.